Hello everyone, I am Dimitris and together we will be exploring the topic of error reporting in C++. The focus of this course is the design of functions that normally return a value, but sometimes they may not be able to do so because an error has occurred. What should they return instead? What should their overall signature be? How do we design them in such a way so that they cannot be misused? I am a software engineer and have been working with C++ for many years, mostly within embedded systems. On the side, I teach. I have taught software engineering courses in Swedish universities and C++ to various R&D organizations. I got some courses on Udemy too, so make sure to check them out. I've got multiple open source projects I'm working on and usually blog about on my website. Please feel free to reach out, subscribe to my YouTube channel, or connect with me on LinkedIn. In this course, we will keep things very practical and code-oriented. That being said, we will start by setting the scene and quickly talk about error reporting principles. Then, we will look at multiple error reporting code snippets, analyze them, and discuss their pros and cons. Specifically, we will look at ways to report errors from essentially C to C++23 and everything in between. So, what is an error? In this course, when we talk about errors, we will not be referring to compilation or syntax errors. While in an ideal world we would be able to catch all programmer errors during compilation, we will not be talking about them either. Instead, we will be talking about errors that occur during the execution of a program. Specifically, errors that are often not programmer errors, but rather environmental. It could be that memory cannot be allocated, the software is trying to access a file that does not exist, or the network is down. The subject becomes more challenging when the functions that encounter the error normally return a value. What should they return instead? So, what is the big deal with error reporting? Recovering from errors is not always possible. Modern programming languages provide a number of ways to convey that something went wrong. Effective error reporting increases the correctness of software and makes it more maintainable. The goals of error reporting are simple. We need to make correct code easy to write and incorrect code hard to write. We should fail quickly if we must and report unignorable and unambiguous errors. Let's examine these concepts in more detail. If an error has occurred, then ignoring it is typically a bad idea. What should we do about it? Are we in a valid state? Should we escalate the error to the caller or a user interface? From a language syntax perspective, C++17 introduced the noDiscard attribute. NoDiscard induces a compilation error if the return value of a function is ignored. You should absolutely use noDiscard for functions that may communicate an error state through the return value. That being said, it is not a serial bullet, as we will see soon. In fact, in all of the examples we will be looking at, we will assume that noDiscard is being used. I have not included noDiscard in the code snippets to make them shorter and easier to understand. To demonstrate the different error reporting techniques, we will be looking at a relatively simple function that reads a file and returns its contents. Based on this description, what do you think can go wrong when reading a file? Please take a moment to think about it and note down your answers. Feel free to pause the video. Well, even in such a simple case, there are multiple things that can go wrong. The file may not exist, or we may not have the permissions to read it. The file could be locked by another process. The file could be too big for our data structures to carry or memory to hold, and so on. So, how do we communicate these errors? More importantly, how do we communicate these errors or the contents of the file? How do we stop the caller from accessing the contents of the file if an error has occurred? In the following lectures, we will be looking at different ways to report errors while addressing these questions. We will evaluate each technique based on its simplicity, expressiveness, and robustness.